Okay, so kind of taking a step back. So I'm going to repeat myself a little bit, having just enabled recording. So today I want to talk about this particular issue because I've been looking into it. So um, I've been talking for a minute or two about Lucene's very basic query planning through these so-called index or doc value queries. So where I was getting to was uh, with numeric ranges. If you have a numeric range and some other condition, Lucene can make this decision of, do I use the numeric range query as a classic numeric range query and iterate through the documents that match the numeric range query and join them with or intersect them with the results of this other query directly? Or do I evaluate the other query and for each document that the other query matches, do a lookup on the numeric field, reading its doc values, and sort of saying like, oh, your value is this. Does that live within the range? Yes, collect it. If not, don't collect it. So yeah, so this is it's kind of a neat rewrite. It's sort of a way of kind of estimating the cost and going down one of two different paths. Well, along with that, so there was this change last year to add similar capability for these multi-term queries, and this can actually be really exciting. There are cases where you say, um, I want to search movies where the movie genre is action and the title has a word starting with A, right? So there are going to be lots and lots of movies with titles with a word that starts with A. Actually, no, that's not a good example because title at that point is a text field. No, I take it back. Let's say you have a keyword field on the movie director's first name. Yeah, because it has to be more of a keyword field because otherwise you wouldn't have doc values. So let's say you're looking for action movies where the director's first name starts with A. So you've got this prefix query, A star, uh, and genre is action. Um, it may be that expanding out that A star you know prefix term is very expensive, right? That because normally the way that would work is it would go and look in the term dictionary, starting with A, and then keep stepping through the term dictionary, collecting all those terms until it hits a term that starts with B, right? And so gather up all of those and collect all the doc IDs into a big bit set, and then intersect that big bit set with the bit set for action movies. So yeah, last year this change was made to allow these multi-term queries to do a doc value rewrite potentially and be wrapped in an index or doc values query. Well, in order to do that, um, Greg Miller did a lot of that work. I used to work with Greg over in Amazon Product Search. So he did a lot of that work. And part of that was like, well, in order to do that, we need to provide a cost estimate for these multi-term queries. And so that's sort of where this issue comes in. It turns out, uh, where did he say the old behavior? Right. Okay. So the old behavior. Right. So yeah, a key thing is that the old behavior was doing this rewrite first. Like it was doing the full term expansion. Now that term expansion could actually be the expensive part, right? Like that's the thing that you're trying to avoid. Well, before Greg reworked this stuff, um, it would do this whole expensive term expansion, only then providing an estimate of the cost of the index form of the query versus the doc values form. So it was providing a true estimate of the cost because it had frankly already done a lot of the heavy lifting. Um, if anything, it was probably kind of slightly overestimating the cost because at that point, well, no, there is still the cost of stepping through matching documents. So if you had a wildcard query or something that matched a whole lot of documents, right, it would sort of suggest to you that like, oh, well, maybe it makes more sense to do the tree traversal over on your other range query if you have one. Well, it turns out that the estimate that he came up with, where did he put that? So I put some comments talking about this. So the estimate, so how can you estimate the cost of a prefix query, a wildcard query, whatever, without knowing what it is ahead of time? Or even a term and set query, right? Where you're saying like, oh, find things that are, this or this or this or this. Well, the approach actually, if you have a prefix query or a wildcard query, you won't, without doing any of this expansion of the terms, you don't actually know how many terms are in your query because you haven't expanded out yet. So your estimated cost will actually be the sum of doc frequencies of all the terms in the field. So it actually ends up estimating that the cost of your multi-term query is really high. It's like everything. So there are a couple of problems that show up with this. So there's the one that this guy, this Ruben encountered, where if the cost of a query is really high, or the estimated cost of the query is really high, it won't get cached. So that was the problem that he ran into. The problem that I ran into, or technically, Vamsi, who's on vacation this week, and so he's not here, but he sits next to me in the office when we're in the office. Yeah, he was faced with this problem where a user had reached out to us saying like, I've got these queries that were really fast on OpenSearch 1.3, and now I've tried to upgrade to 2.11, and they're really slow. Why? Um, and so we kind of dug into it and figured out it's basically because of this same issue. That what was happening was they had a term and set query that was only matching one document. But what was happening was that through this estimate, they it didn't know that that particular term only appears in one document. Instead, it was going into this clause here, where it's saying, well, how many documents in total are matched by this field? And then how many terms are in the field? If you take the total number of documents, subtract the number of terms, and then add one, what's the cost? Well, it turns out that for their case, that was a lot of documents, a very high cost. Now, they were doing this term and set query plus a range query, a numeric range query, where that numeric range query matched a lot of stuff. But it's like, well, this thing's expensive, this thing's expensive. Oh well, let's do both. Right. And so it turned out actually that the first one wasn't expensive at all. It was actually super cheap. But that the range query, because it does a lot of its work up front, was extremely expensive. And so it was very expensively computing this giant set of this giant bit set of matching doc IDs just to be intersected with this iterator of size one. So anyway, so that's an issue that I've been looking at. I have a possible fix that I don't know if I like it. So um, the theory is like, well, we want to come up with an estimate without expanding out the full set of terms because the full set of terms could be very expensive. My thinking is, what if we set some threshold? In this case, I picked 128. I said, you know what? I'm going to estimate the cost as the sum of the first 128 terms. Now, if we have more than 128 terms, so this is where it does sort of a fall through. So like if the for loop completes without returning, we actually just discard this, right? And we go down to the old logic. So this is my proposed solution where we get the true cost if your multi-term query doesn't match a lot of terms. Now there are still cases where like say I do maybe not A star, but maybe I do like X star as a prefix query, right? So I'm summing up all the things that start with X. If there are like 200 of them, but each of those 200 terms each match like one document, the actual cost is still quite small, right? Like it's a cost of 200. But if I sum, but with this logic, I would still give up. So I don't know. Like I feel like this is better than what's there, but it's still not perfect. So I guess my question here is like, does anyone have any better ideas?
I don't know about better ideas, but I have some questions.
Mm-hmm.
Um, so how is this like really? So you do the loop if it's less than 128
Mm-hmm.
items and then you fall back. You're not really fixing anything, right? Oh, you're fixing things only in some cases,
Yes. Yeah.
but the other cases it continues to be the thing.
Yeah. Yeah. So
Um,
I'm fixing the case where the multi-term query has fewer than 100 matches fewer than 128 terms. Or matches, yeah, a
mm,
maximum of 128 terms.
query terms, I see.
Yeah. Yeah. So the idea is like, yeah, if your query is A star,
Mm,
um, if there are 128 or fewer things that start with A,
mm,
then yes, we're actually computing a reasonably accurate cost estimate.
mm. So I had like another slightly different question. So how about like we say, hey, we budget this to like say, I don't know, 1 milli.
Mhm.
And then you say, if I've spent more than 1 milli, I say this is very expensive.
Mm. Well, so yeah, it's a little bit tricky. Like
Mm,
Lucene's cost estimation up till
mm,
now, it's largely focused on uh you know number of matching documents. So yeah, so I've got like two iterators say, right? Like
mm,
it makes more sense to really drive things with this more sparse iterator.
mm.
And so that's kind of what these cost estimates are for, is really to try to say like I think this thing is going to be more sparse than this other thing. So
Yeah, no, but I was just gonna say, it's like, yeah. So basically this is your estimation, and like,
mhm,
yeah, you don't want to spend too much time on your estimation too, right?
mhm. Yeah,
Can
yeah,
you time bound your estimation and say,
yeah,
hey, now I'm out of time. I'm just gonna say I have int max. I don't know. I'm just throwing things
yeah,
out.
yeah. Well, actually, a possibility that I was thinking about as well was sort of take this
Mm-hmm.
and move it down
Mm-hmm.
here because this calculation here is super cheap,
Mm.
right? Because this calculation is like you can see that there's no looping or anything.
Mm-hmm.
It's literally just like
Right.
reading some statistics off of the terms object, right? And these like this get some docfrac, that is literally just like a field read,
Mm-hmm.
right? Like that value is in the terms object. And similarly, terms dot size is in the terms object. Um, so um, so this incidentally the logic here um, is really good for the so-called well, it's pretty good for the so-called primary key use case.
Mm-hmm.
Really only for the term and set query, because actually if you do a prefix query or a wildcard query, right, you still go into this branch, right? Because query terms count is only not -1 for a term and set query. So actually, I kind of take that back. It's not great for the primary key use case for these expanding queries. Um, the logic down here for the term and set query, it's actually able to kind of work out like, okay, well, what is the worst possible case with your query terms? That's like, well, if it's a primary key type thing, then basically, like the sum of doc frequencies and the size are equal, right? Because every term appears in exactly one document. So
Mm-hmm.
if you sum up the doc frequencies of your terms and then you subtract off the number of terms, you end up with 0. And then you add in your query term count because, like, oh, okay, well, yeah, I'm matching 20 terms, right? So those 20 terms will correspond to 20 documents, right? But if you don't have a primary key thing, this is what I argued here. So let's say you have a string field with 10 million distinct terms, uh, and they match 20 million documents, right? Then the code, a query on, and let's say, they're matching between 1 and 3 documents each, right? So they average 2, but some of them match 1, some of them match 3. On average, it's 2. Well, if you have a query on one of those terms in a term and set query, um, it'll end up estimating this like, what if most of the terms match one doc, but this term matches like everything else? So yeah, it will give you an estimate of 10 million and one, which is essentially what was happening more or less with this case that Vamsi was looking at last week. So
I see. Oh, thanks.
yeah.
Hey, Mike,
Hey.
do you think, so for the case of the unique ID,
Mhm.
that may be somewhat common, right? A place
Right.
where this query is actually used.
Yes.
And in that case, the estimate can be calculated relatively easy, like the cost, right?
Mhm.
So even if you send like 1,000 terms,
Mhm. Right.
um,
The cost would be very low.
yeah.
Yeah.
And what would happen in that case here? So,
Right. So that's exactly well. So that would be the fall through case. But yeah, if it's a wildcard query, right? So if it's a wildcard query that or a prefix query that matches on 1,000 terms, you're absolutely right that the actual cost would be fairly small. Now the give or take, right? Because the cost of evaluating those 1,000 terms is like, well, that still kind of costs 1,000 in addition to the 1,000 doc ID lookups. But no, you're right. that's a case where it would actually still be really cheap, but we would still treat it as expensive.
Yeah.
So
So Michael, can we do something like I know it's bad, like if we calculate the average um documents per term, something like that. So we know the total document count and total terms, and we find that ratio out
Mhm.
and use that as like these would be the number of documents matching a term on an average in the segment. So
yeah,
using that, we can, given the number of terms, we can multiply
uh,
that.
almost the catch is that we don't know ahead of time what the number of matching terms is for a prefix query or a wildcard query or a fuzzy query.
Yeah, right. I think they have two cases here where they know number of query terms count and then where they don't
Yeah.
know, right?
Yeah, the one where we know it is a term and set query.
Okay.
Yeah. 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 So for the term and set query, I think yes, I think we could do that.
But at least like we know like how many total terms are there and that ratio we know, right? Not in the query, but in general, like in total terms in the segment, right? So using that, because right now we assume like looking at this condition, like there is one document each term is gonna match.
Mhm.
Instead of that, can we use that number, that ratio, to better estimate the cost?
Yeah. Well, the sum of docfrac divided by terms dot size, yeah, gives you the yeah, the number of yeah, the
Right.
number of documents per term.
Yeah.
The difficulty is, like, let's say in the current segment, you've got like 5 million documents, and you've got some ID field where every ID starts with A, right? And somebody
Right.
searches for A star.
Yeah, I agree. Like,
Yeah. Mhm.
so you are saying like it's better to estimate a lower cost than a higher cost.
Oh, no. It's better to estimate a higher cost,
Okay.
but that we don't want to spend too much cost on the estimation itself. So
Yeah.
yeah,
Michael,
yeah.
this is Lukáš from Ivan. I don't know that much about Lucene API, but if, and I don't know how well anyway. So here you are trying to say basically, okay, so I come up with a magic number which is 128,
Mhm.
which is some kind of threshold.
Mhm.
How about so and you are trying to set up some threshold for a test that may be expensive or not. So how about instead of number of documents, if you enable a user or client to basically say how much time he's able to sacrifice on running
Yeah,
this test.
yeah. Yeah, I think that was Kieran's suggestion as well, right? Like, Kieran, is that
Yeah.
what you were?
Yeah, that was mine.
Yeah, yeah, yeah. That could be an interesting way to approach it. So right now, Lucene doesn't have anything like that.
Yeah.
But no, you're right, and
I think it, because then it's up to the client to say, hey,
yeah,
I'm willing to sacrifice if you can enumerate all the terms under I don't know 500 milliseconds. I'm fine with that,
yeah,
and just do it. If not, then consider it expensive, because that's
yeah,
basically what expensive mostly means, right? How
yeah,
much time. Uh, so that's one thing. The other thing, again, I don't know how common it is in Lucene. I guess it's probably not common at all. But in this case, I can imagine. So you are basically treating this problem as something. Hey, I have some dictionary and I know nothing about it, and I'm trying to calculate something.
Yeah.
Well, that's basically not true, because Lucene can know everything about it because it's been indexing the data.
Yeah.
It is only the fact that it's not been told what kind of aggregate or kind of metadata it should collect during the indexing, because it does not know it, because it does not know nature of the data. And later, when the user sends a query, it cannot do any kind of. So what I'm trying to get in is, so if user is indexing, specific data that the user understands and knows that, okay, in this field, I'm going to have a, I don't know, some kind of unique ID or something like that, then maybe Lucene should be able to accept some kind of metadata calculator for that field that can later answer specific questions about the data.
Yeah. So the main challenge here is not knowing which terms are being matched by the current query until
Yes.
you
Yeah.
evaluate that, right?
Yes,
So
right.
but
still it might be useful in this case, because, well, if you know that you will be mostly using prefix queries, then hey, how expensive it would be during the indexing to just create some kind of histogram for an initial letter only.
yeah,
I mean, this can
not
give
true.
you
Yeah.
some, right?
Yeah,
But
that's
Lucene cannot do this decision for itself. It needs a direction from the user.
that's true. That's true. And you might be able to get some
So at least based on the first letter, how was the upper estimate of.
Yeah. Yeah. So that, yes, potentially, yeah, that could be something where at the very least, you could quite cheaply, certainly at least for the prefix queries and the wildcard queries, if you stored statistics on how many how many documents match terms that contain a particular character, or technically a particular UTF-8 byte. So, yeah, so for the general case, right? So for the prefix queries, if you had A star or even like AB star or A B C D E star, you could get at least maybe a tighter upper bound by saying like, well, anytime I have a prefix query, I'm going to look at my statistics for how many things start with this character. So that actually wouldn't be very expensive to keep as a statistic.
The just trivial
Yeah.
example, but what
Yeah,
I'm saying
yeah.
is that
Oh, yeah, yeah.
maybe the Lucene should have some kind of
Yeah,
opportunity where users can really
that's
because I'm not a mathematician, but I can imagine there can be really some kind of advanced coding and things like that will help a lot in this case.
Yeah.
And perform much better
yeah.
than this trivial example.
Yeah. Like again, even if you were to store how many terms contain how many documents are matched by terms that contain each of the different possible UTF-8 bytes, right? Obviously there are only 256 possible UTF-8 bytes. I don't I don't recall if 0 is actually valid as a standalone UTF-8 byte. But anyway, assume 256. If you had statistics on how many terms start with a given UTF-8 byte and how many terms contain a given UTF-8 byte. That would actually give you, those two pieces of information. You could fairly cheaply get at least potentially a tighter estimate or like a different kind of estimate, right? Because if you had a wildcard query where one of the characters in, like, essentially with a wildcard query, you could go through all of the characters in the wildcard string, skip over the stars, right? But say for everything that's not a star, what is the minimum doc frequency of that character, right? And that would be guaranteed to be an upper bound, not a tight upper bound, but an upper bound on the number of documents, which would at least be tighter than this, I think, or certainly it would be no worse than this, right? Did that make sense as a
Yeah,
sort of,
yeah, something like that.
yeah. That's an interesting idea, actually. Yeah. Huh. Might try proposing something like that. No, thank you very much for that suggestion. Because yeah, no, you're right. There's because logically, if you got into like, okay, well, a single character gives you a bit of an estimate and is very cheap, right? Because obviously there's only 256 different possibilities. If you were to take it a step further and look at two character or at least like 2 byte combinations, right? Obviously that would give you a much tighter bound if you have these 2 byte combinations in your wildcard string, right? So let's say I had star AB star, or say star ABC star as my wildcard, right? An upper bound on the number of documents that match star ABC star would be an upper bound on the number of documents that contain, or sorry, it would be the lesser of the number of documents that contain AB and the number of documents that contain BC, right? Because obviously everything that contains ABC contains AB and BC.
Yeah, I think to some degree this could be today modeled using, I think it's called Shingle Shingle tokenizer or something like that,
Yeah.
right?
Yep.
To some degree.
Yeah.
But basically what I'm talking about is something more general. It's about so when we are indexing the data, or when Lucene is indexing the data, why it can't be instructed to capture some user-defined metrics on the data? I mean, given that it's not too expensive, because then indexing will be very expensive, but because the user basically should know what kind of data it is, and then it can take some kind of benefit of that during the querying, right?
Yeah.
So
the difficulty then becomes, so Lucene tries as much as possible to not force that work out onto the user, right? Now, technically, so if you look at OpenSearch's prefix, so on text fields and on keyword fields, I believe, you can specify index prefixes. So if you know you're going to be doing a lot of prefix queries, you can enable that flag, and that actually takes a completely different code path. So what happens there is at indexing time, it actually indexes those prefixes as standalone terms, and then at query time, when you send this prefix query, it doesn't come down this multi-term query path. Instead, it says, "Oh, okay, I'm going to look in my prefix field for this term." And it's super efficient because you've basically shifted your work from indexing time, or sorry, from query time to indexing time. And that works brilliantly because it's just like a term lookup. You have the actual statistics for that term, and everything is great. Yeah, doing that kind of somewhat more generally is difficult. Well, or
Yeah, definitely.
yeah, but but yeah, no, I think there may be a happy medium where we can collect some statistics cheaply, while simultaneously like yeah, yeah, kind of tightening the estimates, but yeah.
Could you rephrase what you guys discussed? So
Oh,
yeah. So
yeah.
what is the exact statistics that you would capture?
So the two statistics that I'm thinking of, as something that again, we could enable it for everything and it would still be relatively cheap. Would be to say, imagine like while you're indexing your text, right, and you're indexing this field, documents are coming in. You keep track of the two that I'm thinking of are for each character in the terms. And again, I'm playing a little bit fast and loose here because Lucene technically doesn't index text. Lucene indexes UTF-8 bytes. So really, for every byte in the term, I would keep track the two that I think would be really handy would be how many documents have terms that start with a given byte, and how many documents contain terms that contain a given byte. Right. So like so you would be able to in O1 time answer how many documents start with A and how many documents contain Q. Right. And the idea would be that if you have a prefix query, you could look at how many documents start with A, and then if the prefix is longer than that, you could look at the contains statistics, right? And you're taking the minimum, right? Because if your prefix query is ABC star, right, then an upper bound on the number of matching documents is given by how many documents start with A, how many documents contain B, how many documents contain C, or contain terms that contain B and C, right? So all three of those are possible upper bounds, and whichever one is the lowest is your estimate.
Got it.
Yeah. And you can also do the existing calculation that Greg did. And again, like whichever upper bound, like these are all like worst case scenario, sort of very general upper bound on the actual value. Whichever upper bound you find that's the lowest is the one you pick.
Makes sense.
Yeah.
Michael, just a question. Any relation to FST's work? Because if it looks very much as what FST is doing, right, with the prefixes and estimate.
Yeah. So technically, what's happening? This get terms enum. So the Q technically has a term automaton. So it has this automaton that steps over the terms FST. Like it intersects the automaton with the FST.
I see.
So yeah, yes, you're absolutely correct that there is FST stuff going on, but it's basically kind of hidden inside. But technically, it's So this operation here of get terms enum is apparently really cheap. It's basically sort of saying, oh, give me a terms enum that takes this automaton and this terms FST, and it
Mhm.
immediately returns it. The actual evaluation, as far as I can tell, is happening here in the terms enum.next. So that's actually saying, okay, finite stage transducer and automaton, like step through the things that intersect between you. Yeah. Yeah. And that's the part that to me for now is still magic. Yeah. So
Interesting.
yeah.
Because I think the idea you just mentioned, it won't work for text field, right? Because for text field, you apparently will have full match of probably all characters. Which
Yeah.
will
What?
be similar.
Yeah.
With keyboards, probably.
Yeah.
For others, you probably will have whole document set matching it.
Yeah.
I don't know how useful. I mean, how often these queries have been used or not. Is it worth trying out? Maybe yes, maybe not. Yeah, interesting.
Yeah. I don't know. Yeah. So another interesting possibility, because that one that I suggested. So this logic here is actually very good for the term and set query, right? The term and set query that doesn't contain a huge number of terms, right? If you have a term and set query, frankly, in my opinion, you should just iterate through the terms and sum up the individual terms costs, right? Like that's easy. For the prefix and wildcard queries, where you don't know a priori, that's where something like the whole maybe you have per byte statistics. But as you said, if your text is large enough, right? You're gonna have every every piece of text is gonna have a term that starts with A. Assuming that
Very
it's
likely,
written
yeah.
in a Western language, right?
Yeah, it become very, very specific to actually database indexing.
Yeah. Yeah. But yeah. So yeah. Yeah. I don't have a great solution. This again, this particular solution addresses, I think, the original issue that this guy Ruben opened, because he said that the wildcard query returns just one document, which makes me think that it expands out to just one term, right? Because each term must match at least one document. So, right, if the wildcard query only matches one doc, it must only expand out to one term. And then meanwhile, the case that I was looking at, well, technically Bumpsy was looking at and leaned over and asked me for help. Was also something where it's here is a single term that matches a document. So, for this case, I think just evaluating the automaton and stepping over the values, I think it's good. But then, as Tomas said, if your automaton matches 1,000 terms and each of those terms matches one document, the change that I made or the change that I'm proposing wouldn't help you. So maybe we need multiple solutions. I don't know. So this has been a good discussion. Lots of good ideas. And then obviously the other proposal of could we make it time based? Right. Instead of trying to set some arbitrary threshold like I did, instead we could say well, let's try spending a few milliseconds right? Because we're talking probably single digit milliseconds in terms of the time to step through even a fairly large number of terms. But yeah, what cost are you willing to tolerate to get a good estimate? I don't know. Yeah.
It has to be very little compared to the
Mm.
time you execute the query, right? That's the
Right.
True.
Right.
Also,
That's
like
right.
computing time could be tricky. Well, like in a running method, you have to keep checking, like, right?
Yeah. Yeah.
So, and in order of milliseconds, it's gonna be even trickier. So,
Yeah. Yeah.
this won't be one change in this estimate cost, but it would be a generic API level change if
Yeah.
we do that.
Yeah. Yes. Yeah. Yeah. Because that's the other thing. It's like this whole cost thing goes all the way up to like Lucene's whole score supplier concept. Like every score supplier provides a cost estimate. Now, the vast majority of these cost functions are O1, right? Like they're super cheap. Yeah, like this multi-term query cost is, I think, one of the only ones that's kind of expensive. Actually, that's not entirely true. I'm trying to remember for range queries. If you have multi-dimensional range queries, I think the cost estimate can be expensive because you don't know how many leaf nodes you're going to match on partially. Right. The thing that normally makes, like in the one-dimensional case, the really cool thing is that because of the tree structure, usually you end up taking like whole subtrees and saying this range is going to match everything in this subtree. How many documents are in the subtree? Take that number, and then you don't have to recurse. In the multi-dimensional case, it gets trickier because like if you have just an interval, right, you can have at most like a leaf node that straddles the left side of the interval and a leaf node that straddles the right side. And then you have all these nodes and you have this tree interior in the middle. In the multi-dimensional case, if you imagine like a rectangle, you can have a huge number of boxes, right, that match the perimeter of the rectangle. So, yeah. Yeah, so in the even in the two-dimensional case, that cost estimate can be quite expensive, I think.
Mm-hmm.
So
I'm actually curious if that's what Elasticsearch at the time did with a wildcard query, field type, not query type,
no,
but field type. No,
oh,
different. Okay.
no. So actually, the wildcard field type, I read a blog post about this. So
Okay.
remember how I was saying like, oh, what if we kept track of like things with A, B, B, C?
Yes.
Yeah.
Yes.
So it actually wildcard query is actually a little bit more similar to what Rishabh. So Rishabh knows this stuff quite well between the match only text field that supports phrase queries, despite not indexing the right stuff for phrase queries. It does index the right stuff to do conjunctions. And so it can do a conjunction and then on the fly index the individual document at query time and then evaluate a phrase query. So with the wildcard field type, it does something kind of like that, where it indexes like bigrams or trigrams. So yeah, all the 2-character, 3-character adjacent things. Evaluates those. But then takes, at query time, takes that document, looks at actually reads the source, and then lazily, like sort of evaluates the actual wildcard against that. If that makes sense.
Yeah, I guess it does.
Yeah.
Would it help to have not necessarily the same implementation, but similar implementation on the Lucene side? So for this multi-terms, you actually will be
Well, in some ways, that's actually kind of what the doc value rewrite is.
I
Yeah.
see.
Yeah. Well, or sorry, the doc value rewrite in a way is kind of saying, let somebody else do the driving, and then like after, you know, so it's more like the initial implementation is like, you know what, I match everything. So just whatever, just let me match everything. And then, you know, so basically the other clause is what's actually moving you forward through the doc ID set. And then, yeah, it loads the doc value and then sees like, oh, does this doc value actually match this pattern?
I see. Thanks, Michael.
Yeah.
Yeah. Interesting.
Okay. So sorry, we're at time. We didn't actually get a chance to look at Lucene issues, but yeah, we can come back to this next week. I think this discussion on you know, cost estimation was more useful. So thank you all, and yeah, I'll try to get the recording of this posted soon.
Thank you very much.
Cool. Thanks a lot.
Bye bye.
Have a good one, guys.
Bye.